In today's tutorial, we'll walk through creating a scene with a segmented ring with radial wave patterns. The focus here is going to be on building the scene, so we aren't going to get into the theory and mechanisms involved. If you're interested in that stuff, check out the videos in the RayTK intro series. We'll be using RayTK version 0.33, so make sure you're using at least that version. Check the video description for a download link. Start by dropping the toolkit talks into your project. I like to do that at the root outside of the main project comp, but you can put it wherever you want. We'll start by setting up the renderer. Open the palette with the Alt-R shortcut and create a Raymarch Render 3D. Add a null top connected to the output so you can see the rendered image. Select the renderer and open RayTK's Editor Tools menu with Alt-Shift-R. Under Add Camera, choose Look at Camera. On the camera, increase the FOV angle to 50 and set the position to 0, 2, and 5. Select the renderer again and open the Tools menu with Alt-Shift-R, and then under Add Light, I'm going to choose Point Light. On the light, let's set the position to 7, 12, and 9. Next, we'll set up the SDF that we'll be repeating to form our ring. Create a Torus SDF and connect it to the first input on the renderer. Reduce the radius a bit to around 0.4 and reduce the thickness to around 0.05. And we'll keep the axis on Y. This is going to be the cross-section of our main ring. Create a radial slice operator, and we can insert that between the torus and the renderer. Set the axis on the radial slice to Y, and then increase the angle width to around maybe 130. This operator cuts a slice out of an SDF around an axis. The center angle changes where the middle of that slice is around the axis, and the width controls the number of degrees of width along that slice. Later on, we'll use a field to control that center angle parameter. Switch on smoothing and decrease the smooth radius a little bit to around 0.1. That tapers out the edges so that we don't get a hard edge where it cuts off the torus. Next, we'll repeat this shape around the z-axis to form our main ring. Create a modulo polar and insert that after the radial slice for the renderer. Increase the first part of the offset to 1 to spread those out from the center axis, and then increase the number of repetitions to around 32. Now we can start to see the shape of the main ring made out of those cross sections. Because of how modulo polar works, we can increase the repetitions as high as we want without it having any noticeable impact on performance, since it isn't actually repeating the work of those toruses for each copy. It's just sort of creating reflections of the original one. This is discussed in more detail in the repetition filters tutorial. Next, we'll use a wave to vary the rotation of each segment. To do that, we're going to need to identify each segment using a variable from the modulo polar. So select the modulo polar, open the editor tools with Alt-Shift-R, and under reference variable, you're going to choose normalized step. This gives us the number of which segment we're operating on, scaled down to a 0 to 1 range. Create a wave field operator, and we're going to connect our variable reference to its coordinate input. Then connect the output of the wave field to the radial slice's center angle field input. Increase the wave's amplitude to 360, and then change the wave type from sine to ramp. This gives us a continual increase that goes up to 360, so it wraps cleanly as long as our period is 1 divided by an integer. Let's set the period to 0.5, or 1 divided by 2. And that gives us 2 repetitions of that wave as it goes around. By changing the phase parameters, shift the wave around the center axis. We'll animate this parameter later on. Next, we'll use a field to vary the thickness of the cross sections to create ridges. We'll do that using the thickness input on the torus SDF, with a field that's based on the angle around the torus. Select the torus SDF and open the Editor Tools menu with Alt-Shift-R. Under Reference Variable, choose Normalized Angle. Then create a wave field and connect our variable reference to its coordinate input. Then connect the output of that to the thickness field input on the torus SDF. I'm going to zoom in a little bit on the bottom here so we get a better view of one of those segments. On the wave field, change the period to 0.25. And that gives us 4 repetitions of the wave as it goes around the segment. But we need to increase our offset so that we don't have it go down to a thickness of 0 or negative. So let's increase the offset to around 0.6 and then drop the amplitude down to around 0.4. That gives us values ranging from 0.2 to 1. The sine wave is okay if you want sort of an organic look, but to get a more mechanical look, we need to use a different type of wave. Let's change the wave type from sine to square. This does give us sort of a mechanical look, but if you zoom in close and look at the places where it transitions from the thicker to the thinner part, we get some render glitches. And that's because this thickness is changing too rapidly in too short of a distance, and the renderer doesn't know how to handle that. So to fix that, we could use one of the other wave types, like additive square, and that will smooth out that transition a little bit. But another issue which the additive square won't fix is that we don't have any control over the width of the large and small sections of that wave. Instead, we can provide our own type of wave function with a different shape. Create a pausing wave function operator and connect that to the wave function input on the wave field. This type of wave lets us control the relative width of the low and high sections of the wave, and it applies a smooth transition between them, which fixes the issue with the render glitches. Before we adjust those settings, let's increase the number of repetitions of that wave around the cross-section rings. I'll go to the wave field, and let's change the period to an expression like 1 divided by 12. That gives us 12 repetitions around that whole ring. And remember that we're using that radial slice to get only a section of that full ring. The wave that we're using here doesn't take into account that radial slice. and that means that it moves independently from the slicing. Now on the pausing wave function, let's set the low width to around 0.3 and the high to around 0.1. That gives us these kind of little ridges with slightly larger indented areas. Then go to the wave field and try changing the phase, and that will shift those ridges around the cross sections. We're going to add some animation to this later on. Next, we'll add another wave to vary the thickness for each ring, similar to what we're doing for the slice angle. Create another wave field operator. So we want it to be based on the same type of thing that we're using for that twisting. So we can take the variable reference that we're using to control the center angle on the radial slice and just copy and paste that. And connect that variable reference up to the coordinate input on our second wave field. Next, we need to add this to the wave that's producing the ridges. So select both wave field operators and open the editor tools with Alt-Shift-R. Under Combine Fields, choose Add, and then connect this new Combine Fields operator to the thickness input on the Torus SDF. On the second wave, let's decrease the amplitude to around 0.2. And we can leave the offset at 0. The goal here is to have it produce a range that doesn't cause any of those cross sections to disappear entirely. And also to avoid having the sections become so thick that they come up against the edges of that modulo polar that's tiling them around the center axis. Try changing the phase parameter on that wave, and you'll get a similar kind of shifting pattern going around, kind of like what we're using for that twisting. We're going to add some animation to this later on. Next, we'll set up the material. We'll be using a combination of diffuse and specular shading, along with some rim shading for highlights. Create a modular matte, and we're going to insert that between the modulo polar and the renderer. Then, with the modular matte selected, open the Editor Tools menu with Alt-Shift-R, and then under Add Diffuse, choose Orin Nair. On the diffuse contrib, set the roughness to around 0.3 and the albedo up to 1. And then choose a color for it. I'm going to go with kind of a pale green, but you can use whatever you like. Select the modular matte again, and open the Editor Tools menu with Alt-Shift-R. Under Add Specular, choose GGX. On the specular contrib, increase the Fresnel to 1, and we can leave the roughness around 0.5. Let's pick another color for this. I'm going to go with an orange. Then open the palette and create a rim contrib. And we're going to connect that to the next available input on the modular map. Increase the thickness to around 0.4 and the blending to around 0.6. That gives us a bit of a glow around the edges there. And choose a color for the rim shading. I'm going to go with kind of a pale blue. Next, we'll add another feature to the surface that we can switch on if we want. We'll use an inverted cylinder to create a tunnel and then combine that with our ring. Create a cylinder SDF. and set the axis to Z and switch on infinite height, and then set the radius to around 1.4. Then create an invert operator, and we're going to connect the cylinder to its first input, or only input. Next, we need to combine this with our existing surface. So select the modulate polar and our invert, and then open the editor tools with Alt-Shift-R. And under Combine SDFs, choose Smooth Union. And then let's connect the combine up to the first input on the material. And suddenly everything disappears. That's happening because our camera is now outside of the tunnel. So let's go over to our camera and then decrease the Y position down to 0. Now we're back inside the tunnel. But since we're seeing the inside of the tunnel, it's pretty much filling the entire rendered image. What we want is to have the blending, but hide the rest of the tunnel. We can do that by assigning surface colors to the ring and to the tunnel. Create an assign color operator and insert that between the invert and the combine. Then set the color on this to black. Everything disappears because of how the combine handles the case where one of the inputs has a surface color and the other doesn't. So let's add a color to the ring shapes. Create another assign color and insert that between the modulo polar and the combine. And then we're going to keep the color setting on that as white. That means that it just keeps the same shading colors that we already set up in the material without adding any other tinting. Now we can see the ring and part of the tunnel where it's blending, but then the rest of the tunnel disappears. Let's go over to the combine and drop the blend radius down a little bit to around 0.2. Just enough to get us a little bit of blending on the sides there. If you want to switch off this blending, you can just switch off the enable setting on the combine operator and we're back to our original surface. Now we can set up our animation using the phase parameters on several of the wave fields. So let's go over to the wave field that's producing the ridges on those segments. Select that operator and open the editor tools with Alt-Shift-R. And then under Animate with Speed, choose Phase. Then on the speed generator, drop the speed multiplier down to around 0.8 to slow it down a little bit. Then select the other wave that's producing that thickness variation around the center axis, and we're going to do the same thing. Open the editor tools with Alt-Shift-R, and then under Animate with Speed, choose Phase. For this one, we can drop the speed down to around 0.4. Then go over to the wave field that's controlling the angle on our radial slice. And we're going to do the same thing. Select the wave field, open the editor tools with Alt-Shift-R, and then under Animate with Speed, choose Phase. On this one, let's drop the speed multiplier down to around 0.1. Before we finish, let's clean up the render quality a little bit. If you zoom in, you'll notice that some of the areas along the edges have a little bit of aliasing on them, particularly if you go in close. So in an ideal world, the solution to this would be to increase the anti-aliasing setting on the renderer. So let's try that. Increase the anti-alias to 2. It's going to stall briefly. while it recompiles the shader. Now you're likely going to notice a pretty significant drop in frame rate. That's because our renderer is now doing twice as much work as it was before. If you have a really powerful GPU, this might not be an issue, but at least on the 3080 that I'm using, it's a problem. So let's switch it back to 1. Instead, we can use a separate anti-aliasing pass after the renderer. Create an anti-alias top, and we're going to insert that right after the renderer. This fixes the anti-aliasing without a frame rate drop. This operator uses a technique called enhanced subpixel morphological anti-aliasing, which you can read about more on the Touch Designer wiki page for this operator. But in short, it finds pixels that look like aliased edges and blurs them a little bit. And that's it for our scene. So to recap, we're using a Torus SDF that's being sliced into a segment using a radial slice. And we have that radial slice taken on the same axis that the torus is going around. Then we're using a modulo polar to create copies of that going around the z-axis. And that's going to create our ring. We're then using the index of the segment to control a wave that's varying the center angle rotation of each segment. We're also using that same segment index to control another wave field that's adjusting the thickness of each segment. And then within the torus, we're using the angle around the torus with another wave field using this pausing wave function to create those ridges along the cross sections. Then we are combining that using smooth union with an inverted cylinder that creates a tunnel along the z-axis. We're then using a modular material with diffuse and specular shading and some rim shading for highlights on the edges. And finally, we're cleaning up our render using the anti-alias top to smooth out aliased edges. Some potential next steps include varying the angle on the radial slice, similar to what we're doing with the center angle. Or you could duplicate all of these operators and create a whole other copy of those and then combine it with this copy before going into the modulo polar. And if you adjust the torus radius on that second copy, you can get a second ring of segments within the other one. And if you change the wave settings on them, you can get them to move at different rates or something like that. So I look forward to seeing what you all create with this. And if you post on social media, use the RayTK hashtag so we can see what you're doing. If you're interested in supporting RayTK development, or you want access to an enhanced version of this scene and other exclusive downloads, subscribe to my Patreon. As always, thanks for watching, and make sure to like and subscribe.